Hey, morning everybody. We're going to start with engine talk. Okay, we're going to learn today about engines. I mean, there's a lot to learn about it, so it'll take some time. We'll go over it bit by bit, and you'll all be pros by the end of this, okay? All right. What is a vehicle engine? A vehicle engine is a machine that converts fuel into mechanical energy. Most cars use internal combustion engines where fuel is burned to produce engine power. Key components of an engine. So, cylinders. This is the engine block. This whole thing is called an engine block. And these, 1, 2, 3, 4, are called cylinders. Okay? What size engine would this be? Any guesses? It'd be a 4-cylinder engine. Right on. So these little holes here, that's where coolant passes through. Those are called water jackets. That's where coolant goes through to make sure the temperature is maintained, not overheating. Pistons. Pistons move up and down inside the cylinders, transferring energy to the crankshaft. So these are pistons. Again, this is a 4-cylinder engine. 1, 2, 3, 4. These are the pistons here. Okay, that's inside. That's a cutaway of the inside of the engine. Okay. Crankshaft. Crankshaft converts the piston's linear motion into rotational motion. So each piston is connected to the crankshaft here with connecting rods. Okay, and there's a swivel in there, so the piston can move up and down depending on which way the crank's going. Camshaft. Camshaft controls the opening and closing of valves for air and fuel intake and exhaust. So this camshaft here, this is the exhaust, okay? And these things here are called cam lobes. When this cam rotates, the cam lobes rotate and opens the valves, okay? So there's exhaust valves on this side, intake valves on this side. There's the pistons, crankshaft, and the crankshaft connects the camshafts by the timing chain. Okay. Spark plugs. They ignite the air-fuel mixture in the cylinder. So, the intake valve will open, letting air come in. Same time, the computer tells the fuel injector to squirt some fuel in there. Then the spark plug ignites, causing a combustion. Boom. Here is a picture of a piston. Here's a piston. You see on top of the piston, see it's all carboned up with black. That's from the explosions all the time. All the combustion happening there, okay? Spark plug igniting, causing it corrosion, okay? Valves. Valves regulate the flow of air, fuel, and exhaust gases. So again, the cam turns around by the chain, right? And these cam lobes come around and open up whichever valve it needs at that time. So see how all the cam lobes are in different positions? Because you can't have more than one valve open at one time, right? So one cylinder open at a time. The red ones are the exhaust valves, green ones are highlighted intake valves. Okay? Pistons, crankshaft. Another picture of it. So, intake valve opens, allows air to come in there. At the same time, the injector squirts fuel in there. Piston comes up, spark plug ignites, piston goes back down. That's called the compression stroke. We'll go over that in a minute. Okay, connector rod to the crankshaft, that's the piston, exhaust valve. Okay, so there's major systems of the vehicle, of the engine. The fuel system. It's responsible for delivering fuel to the engine. It includes such parts as fuel tank, fuel pump, fuel injectors, and older vehicles are the carburetors. We don't have those anymore, it's all fuel injector vehicles. The fuel system ensures that the engine receives the right amount of fuel for combustion. Cooling system, we went over that last week. Cooling system regulates the engine's temperature to prevent overheating. It includes the rad, water pump, thermostat, and coolant. This cooling system ensures that the engine operates within optimal temperature range. Lubrication system reduces friction between the engine's moving parts. It includes oil pump, oil filter, and oil pan. The lubrication system ensures that the engine's components are properly lubricated to prevent wear and tear. So the oil stays below here because this piston goes up and down thousands of times, up and down. So oil's got to stay lubricated between here. What do you think would happen if there's no oil between here? Yeah, it'll like heat up and it'll even seize. It'll seize the piston. Exhaust system. Exhaust removes burnt gases from the engine. It includes the exhaust manifold, catalytic converter, muffler, and tailpipe. The exhaust system helps reduce emissions and noise produced by the engine. All right, so we're talking right now about the 4-stroke engine. There's also a 2-stroke engine. Any ideas what machine or vehicle would have 2-stroke engines? Dirt bikes? Exactly. Any other guesses? Lawnmowers, weed whackers, any small engine like that are usually boats. Boat motors are usually 2-stroke engines. But we'll go over 2 strokes next week. We'll talk about that. Okay, this is the intake stroke. The intake valve opens, allowing a mixture of air and fuel into the cylinder. So this intake will open, allows air to come in there. Okay, that's the intake stroke. So this piston is going down right now, causing a vacuum, a suction, pulling air in. Okay. Next, we have compression stroke. Yeah, the intake valve will be closed. Both valves are closed. And the piston compresses the air and fuel mixture. So the piston's coming up now, compression all the air and fuel. And when you compress vapor or liquid, it gets very hot. Very, very hot. All you need now is a spark to ignite it. And then we have the power stroke. So this is when the spark plug ignites the air and fuel mixture. Spark plug ignites the compressed mixture, causing an explosion that pushes the piston down. So it'll explode on top of here. Once the spark plug lights everything, explodes and pushes the piston down. That's the power stroke. That's where you get the power from. And exhaust. Then exhaust valve will be opened by the cam lobe. Piston will be coming up, pushing all the exhaust out through the valves, into the exhaust manifold and out through the tailpipe. Okay, I got a nice video here to explain everything. And yeah.
The moment invigorated.
Operation of the internal combustion engine, or ICE. The internal combustion engine converts the combustion energy of the fuel inside the engine into mechanical energy. One type of internal combustion engine is the reciprocating piston engine. The vast majority of vehicles are powered by a 4-stroke reciprocating engine. In this video, we will go over the operation of such engines using the example of a 4-stroke piston engine powered by gasoline. We can now see the crank mechanism and the valve timing mechanism. The former is propelled by the energy released during fuel combustion and converts such energy into rotational, mechanical energy. The valve timing mechanism is needed to open the inlet and exhaust valves. It can be put in motion by gear, belt, or chain drive from the crankshaft. For the sake of simplicity, we will only review the operation of one cylinder. The engine's operation cycle consists of 4 strokes, or 2 crankshaft revolutions. The 4-stroke cycle is then repeated. Stroke 1, intake. Stroke 2, compression. Stroke 3, power. Stroke 4, exhaust. During a stroke, the piston travels between 2 extreme positions known as the top dead center and the bottom dead center.
Down here is where the oil is.
Two-stroke engines exist as well, but they are rarely found in cars. Stroke 1. Intake. The piston travels down from top dead center to bottom dead center. The cylinder volume expands, creating vacuum pressure.
Piston pulls down because
At the same time, the camshaft causes the inlet valves to open,
That's the
allowing the fuel-air mixture to enter the cylinder. In modern-day vehicles, gasoline is supplied via an injector, whereas in the past, carburetors performed this function. The stroke is completed when the piston reaches bottom dead center and the inlet valves close. The second stroke is compression. This stroke starts at bottom dead center and ends at top dead center. All valves are closed. The cylinder volume is reduced, causing the fuel-air mixture to compress. The compression raises the cylinder's temperature and pressure. As the piston approaches top dead center, the spark at the spark plug ignites the fuel-air mixture. The stroke is finished when the piston reaches top dead center. The third stroke is the power stroke. This is the climax of combustion. The combustion process generates a large amount of heat, and the cylinder pressure can get up to 900 psi.
900
The pressure of expanding gases causes the piston to move from top dead center to bottom dead center and turn the crankshaft via the connecting rod, thereby converting thermal energy into mechanical work. The stroke completes when the piston reaches bottom dead center. The fourth stroke starts at the bottom dead center and ends at top dead center. The camshaft opens the exhaust valves, and the piston expels the exhaust gases from the cylinder. When the piston approaches top dead center, the exhaust valves close, completing the last stroke, the exhaust, and the entire operation cycle.
So that's a 4-stroke.
The operation cycle is then repeated. 3 subsystems feed the engine with fuel and air, and then expel exhaust gases. The intake system, the fuel supply system, the exhaust system. Furthermore, normal engine operation necessitates the use of the lubrication and cooling systems. The proper operation of these systems extends engine life.
So as I told you before, below here is where all the oil is, and up here is where the combustion happens, right? That's air, fuel, right? Do we want oil up here? No, we don't, because that's going to burn oil. So what's going to stop the oil from coming up here is these things right here. These are called piston rings. Okay? That's oil seals. That keeps the oil below. So up here, we don't want any oil, we just want air and fuel.
But we are watching the engine in slow motion. In fact, the crankshaft turns an average of 700 revolutions per minute at idle speed.
That's an idle, you're not driving.
The upper limit on production cars reaches 8,000 revolutions per minute.
That's right.
Engine speeds in Formula One cars can get as high as 22,000 revolutions per minute.
Crazy.
You can check the revolutions per minute value on an instrument called a tachometer on your car's dashboard. The operation of the engine begins with the car's starting system. The starter motor starts spinning, engaging the flywheel. The flywheel then stores the energy from the power stroke to use it until the next power stroke. The strokes alternate in different engine cylinders in a certain sequence. This is known as the engine firing order and is required for more stable engine operation. The firing order for this engine is 1, 3, 4, 2, It means that the power stroke occurs in the first cylinder, then the third, fourth, and finally the second cylinder. The sequence is then repeated. Please note that gasoline engines are spark ignition engines, since it is the ignition system, namely the spark plug, that ignites the fuel-air mixture. The primary goal of this system is to ignite the fuel.
So they talked about the firing order. So this firing order is 1, 3, 4, 2. Manufacturers do that so that the engine's not out of balance. So if it was 1, 2, 3, 4, it would be more of a, you'd feel it more. So this is more even. It was 1, 3, 4, 2. If it was a 1, 2, 3, 4, it would be a lot rougher. That's why the manufacturers do that.
Ignition timing is critical to the efficient operation of the engine. There is some time between the appearance of a spark and the complete ignition of the fuel-air mixture and the maximum gas pressure. The piston moves some distance during this time. For maximum engine efficiency, the piston must be within 10 to 12 degrees of top dead center at maximum gas pressure. It means that the ignition system must start in advance. The moment at which the spark plug fires is called
for us. We'll continue that later on next week. Yeah. Can you turn the lights on, please? Yeah, all of them. Yeah, thanks. Okay, any questions about that? There's a lot to take in, so we'll go over many times. Okay. Like I said, piston, connecting rod. What is the connecting rod connected to? Crankshaft, right? It's connected to the crankshaft. What stays below here that we want to lubricate the engine with? Engine oil. Okay. What happens up here? Explosions, air and fuel. What are 3 things an engine needs to start? Air is one, yes. Fuel is another. Spark. Air, fuel, spark. If there's one of those missing from any, say the spark plug isn't firing, isn't working, it's dead, it's broken, whatever, then this cylinder becomes dead. This cylinder no longer runs. So this vehicle will be running on 3 cylinders. So what do you think would happen if it's only on 3 cylinders? It'd be boom, boom, boom. You really feel it. It'd be misfiring. Okay? So everything's got to be working. Everything's timed perfectly. Everything's got to be running properly. What else was I going to say? Yeah, this is a timing chain. This connects the crankshaft to what? What does this connect to? Any ideas? What opens up the valves with the lobes? Camshaft. So this connects the camshaft to the crankshaft. The crankshaft spins, and the camshaft turns perfect timing so that the valves open at the right time. Okay? Any questions, comments, concerns? Okay, assignment. We're gonna go, so we got the engine out yesterday of that Buick. We're gonna walk around the shop, and I want you to take a picture of 2 things we talked about today. And then come back and show them. Good? Good.